Students, now in the second part, we will discuss about the properties of angles formed by a transversal and two parallel lines. So if lines are parallel, then the three angles, that is interior, alternate and corresponding, we will see their properties. So there are three properties. Property number one, the corresponding angles formed by a transversal of two parallel lines are of equal measure. That means corresponding angles are of equal measure. They are congruent. Okay. Whereas second one, the alternate angles formed by a transversal of two parallel lines are of equal measure. That means if angles are alternate between two parallel lines, they are also of equal measure. They are congruent. Okay, so two properties. Corresponding angles are congruent and alternate angles are congruent if lines are parallel. Is it clear? Third one, if two parallel lines are intersected by a transversal, the interior angles on either side of the transversal are supplementary. Remember, this is supplementary, not congruent here. Supplementary means when sum of measure of angles are 180 degree. Okay, this property we have done before also. So I'll repeat again. Supplementary angle means when sum of two or more angles is 180 degree, then they are called as supplementary angle. Okay, so interior angles, that is on the same side of the transversal, are always supplementary when lines are parallel. Okay, so these three properties, they refer to the parallel lines. Is it clear? So these three properties we are going to prove in form of theorems. So I will not refer first corresponding and alternate. I will refer to the interior angle theorem. This theorem is indirect proof. Is it clear? So we are going to prove in a different way. We will assume that the question which has been asked to us is actually wrong. So if it is wrong, some other possibilities may be there. That is how we prove. And if our possibilities are right, then our statement is wrong. If possibilities are wrong, then obviously the statement should be treated as right. Okay. So the same property, the third one, I will write it as a theorem. So theorems can be asked for proof. Okay. Simply prove that if two parallel lines are intersected by a transversal, the interior angles on either side of the transversal are supplementary. So I have to prove this statement. Okay, any statement which can be proved in geometry, we call it as theorem. Okay, so I can prove this statement, so that is why I call it as theorem, isn't it? Now, I have drawn a line L and M. Okay, whatever is given in the statement, I will write it as given. So names can be kept by me only. So I can keep the name as line LM or line NL, whatever name you want to give, A and B. Okay, so I have kept here line L and M. So line L is parallel to line M. This is given data because they have already said two parallel lines. Line N is transversal because they are saying it is intersected by a transversal, right? And from figure I have named four angles A, B, C, D. So same I have written in the given data. So whenever you are trying to prove a theorem, remember a relevant figure has to be drawn. Without a figure, if you write proof, it is invalid. Okay. So I have drawn a figure which depicts all the data of the theorem. Isn't it? And what is the question? What I have to prove? I have to prove that interior angles are supplementary. That means I will prove A plus B equals to 180, or on either side C plus D is equal to 180. Right? Now as I said that this is indirect proof. So I will take A plus B less than 180. So let's assume that A plus B is less than 180 or A plus B is greater than 180. Right? So the third statement obviously is what I want to prove, a plus b is equal to 180. So first I have to check whether first, second statements are right or wrong. So if a plus b is less than 180, if this statement is true, then line L and M will intersect on the side where A and B are formed. Okay, let's see the reference figure. See, if I say that A plus B is less than 180, what will happen? This will form a triangle because I know that sum of all angles of triangle is 180 degree. That means if these two are less than 180, so obviously this is going to be more than 180. So they must intersect at some point if I extend it, isn't it? So this is totally contradiction. This is not right because I am saying that L and M are parallel, so they cannot intersect according to the postulate of Euclid, isn't it? So my case 1 is wrong. This is not right, isn't it? Now when I take case 2, that is A plus B is greater than 180, so obviously C plus D should be less than 180. Why? Because linear pair of angles are 180 degree, isn't it? So in this case also they are going to intersect on the side where C and D are formed, isn't it? So again this is also contradictory. So my both cases cannot be possible, so they are impossible cases, isn't it? So what is left with me? Only the last statement, that is A plus B is equal to 180. Hence if two lines are parallel, in that case sum of interior angles has to be 180. It cannot be greater than 180 or less than 180 if lines are parallel. Okay.